Alright you guys, welcome back to the Magnetic IDEX channel. Here's another unscheduled video to show how I machine this pulley without a lathe. The cool part about zero gravity coupling is that this 31, I think, 29 gram coupling replaces this 232 gram stepper motor. So this stepper motor is now hard mounted to the frame of the printer, and the zero gravity coupling is doing all the torque transfer to my belt. This one tiny part replaces all of the complexity and all of the pulleys and extra belt lengths on the Core XY printer. That's why I think this is really cool. The star of the show is this pulley, and how are we going to machine it? So the first step you saw in my previous video, I have this little jig where I simply knock out the collar. Not going to repeat it on this video. Go back to the previous one to see it in action. It takes 2-3 taps to pop this ring off, and what you end up with is this naked pulley. And then I'm going to keep exactly 7 millimeters of the teeth here, and the rest turn down to 10 millimeters, so I can use a standard 10 millimeter ball bearing on both sides, one here and one here. Or actually, on the zero gravity coupling, what we do is we press in this portion into the pulley, into the zero gravity coupling, back out these screws to lock in. So then I have perfect lock here. And then the part that we machine off will receive a 10 millimeter bearing. For this little drill press trick or manual drill work, I made a simple jig like this with ball bearing pressed in to both halves. So let's assemble this really quickly. And to assemble it, you need either a 5 millimeter shaft. This is the original Y-axis shaft that was driving both Y-axis belts on the FlashForge Creator Pro 2. And this is the second printer that I've been slowly cutting down to length to make various pulley axles. The drill bit will go through. I'll leave some material here. Sometimes you need to persuade it a little bit. So that's my bearing. Then this will go in, and then the drill bit. So this flat here is my my work surface to be removed. And the cool part is that bearing, ball bearing that's pressed in here, the OD of that bearing is exactly 10 millimeters. So I really can't easily go under that dimension. You need to leave enough material for the ball bearing, and there is a little indicator here where the flutes of the drill bit start getting sharpened. So I need to run it on a ball bearing a little bit sooner. You may ask, Dmitry, don't you have access to a lathe? Could you buy one? A cheap one on eBay or something? Well, yes, but I don't trust myself. I'm not that good to be able to dial in my lathe to have this part run true. I don't trust myself, don't have enough skill. And so sometimes it's actually easier to make your own tool or your own jig. So this is how much I have left here. This goes on like so, and then we drive this in. Again, it looks ghetto. It looks like, Dmitry, you don't know what you're doing. It's so primitive. But the cool part is, this is running on ball bearings. The concentricity of that is virtually assured within the tolerances of the ID of the pulley. And so that dimension I can trust. And so what will end up here will be concentric to our drill bit. And so I think this is actually a more reliable way for a inexperienced lathe operator such as myself to get precision that I otherwise wouldn't really be able to obtain. If I only had a drill nearby that I could use for this, but actually this drill bit would be in the way. So I already locked the set screws, so I can't easily remove that. And so let me just finish this off. And what we'll do is lock this in to the drill. So that's, can you see that on screen? So that's, and then on the drill, I put in these rubber bands that I just lost one, but the cool part is if you have just the right amount of rubber bands, it can hold your speed. So let me replace this ripped one and be right back. I'll actually pull the battery off, put 2 more rubber bands on. Interesting thing I discovered is that if this is pre-triggered and you put the battery in, drill is smart enough not to turn on. So that's kind of cool. So you have to go back to origin or off position, and then you can do this. So with rubber bands, pretty easy to modulate your speed, which is kind of neat. And then what tool are we using to turn this with? And that is just a regular old file. It's a relatively coarse file. I use this to deburr Picolino extruder gears actually. So what we'll do, see, make sure I don't close this off, is run the file along the, what we'll do is speed this up. And you can see how the teeth are getting removed. Let me bring that closer. So we're beginning to remove. I can see a lot of aluminum shavings. I should put away all these other parts. And let me just finish this off. And sometimes it helps to flip the direction. So see how the file feels in your hands, and maybe reverse it. So then we'll speed this up. So now it's kicking, and just work the file. And you can see all the teeth are gone already. And I'm getting close to my final dimension. Again, the file needs to be flush here. So let's turn this back on. And now we're approaching the position where the file doesn't even catch much of the aluminum. So I'm getting close to being done. Let me take another pass at it. Watch your tool. So you can see that is almost flush with the tool, with my jig, and I can still feel a little bit of aluminum, but I'm actually grinding the bearing, so it is a sacrificial bearing at this point. Now what we can do is disassemble the fixture, and extract our machined pulley. Let's have a look. So you can see what this looks like at the moment. We'll remove the rest of it and then put some calipers on it. So now we pull this off and take our drill bit out of the fixture. Sometimes you may need to actually tap it out. I tapped it out. It's a little tight on the ball bearing. This is my machined pulley, rough machined. Now what I can do is put a caliper on this really quickly. Our first pass, we're at 10.23, and the rest we can chuck this drill bit back in and just touch this up with sandpaper. So what we'll do is we'll take the second pass at it. So interesting, my first attempt, I was within 0.1 millimeter. And so what you need to do is just grab a strip of sandpaper, cut this off with scissors so it's nice and easy to work with. And then the next step will be turn the drill back up. And next is to remeasure. This time you start measuring it more frequently. And so we're at 10.18. So we're getting close. I may need a new piece of sandpaper, but this is the tricky part. If it catches just right, it'll rip out of your hands. So really be careful, practice. So it wants to catch, and sometimes it's actually better to speed it up first. Once the sandpaper is short, it's a little scary, dangerous, but again, practice. Don't lock this, don't put a lot of pressure on your fingers. If it catches, let it rip out of your hands instead of pulling you in and getting you hurt. So just gentle, work the sandpaper back and forth. If you want to try, reverse it. Now it'll pull in the other direction. All right, and we're back. I got a fresh sheet of 120 grit sandpaper, so let's put this right back in, like so. And we'll go at it again. Turn on the drill. If there's ever demand for something like this, I'm sure we could special order this type of pulley. So we're at about 10.13, something like that. Let's get a fresh side so you can see the oxide is getting used up. Now let's do this again. Okay, let's give this a check. .03, 10.05, 10.01. It's still warm. It's probably going to measure slightly less in a second. And kids, don't try this at home. So I actually went a little aggressive and ripped through the sandpaper. So that's also a possibility. We are on 0 and 993, 992. This will be a very nice fit with the ball bearing. This is the 10mm bearing, and it just slides on just. So what I have also printed is this little cap that goes on a bearing, and then I can press this together so that I'm pressing on both inner and outer race. The worst thing you can do to a bearing is just apply the pressure to the outer race when you press these together. So it will go in. I will tap it in gently, again using this tool, this jig. Again, probably the biggest takeaway is that with the 3D printer, if you don't have expensive equipment or the know-how how to use a lathe, for example, a simple jig like this can save the day. We went from a pulley like this to a pulley like this with very little effort, and the concentricity here is absolutely phenomenal. I'm actually going to use this pulley as an idler, so I'll press in a bearing here and here without any axles. This will work as an idler for this. Some other things that I've been working on really quickly. Let me show you something super simple. So this is my tensioner. This is the y-axis block. It gets bolted to the original FlashForge Creator Pro. So that gets screwed in here. This is my zero gravity axle. This is my 8mm y-axis rod, and this is a tensioner. And the cool part is this tensioner bolt used to fall out during assembly, and so I just put a couple of 3 little radial bumps here, so it just clicks in place. And during assembly, before I actually engage the pulley here, the pulley carrier, this little sub-assembly is self-contained, so I can quickly and easily mount my gantry into the frame without having all these belts and everything run yet. So that makes it nice and simple. Same thing on the non-zero gravity side. So clicks in so nicely. This bolts in to the frame. This is my tensioner. This is my 8mm axle. So that goes in like this, and I can adjust tension from the front of the machine. Let me put the zero gravity coupling back in here. So what I'll do is I'll remove this bearing that was in here for show. Pop this in. Press in the bearing. So now that is nicely installed here. And then my 3mm, actually it's a 1/8 inch shaft, that goes in like so, and that slides and turns really easily. So again, this thing here replaces all of the complexity of Core XY, or simply moves the X motor to the frame on a conventional gantry like the Replicator or the FlashForge Creator Pro, where the X-axis motor used to be riding on this block with the y-axis on the y-axis, where now it's just 13% of the original. By the way, listen to this. This is the coolest ball bearing arrangement I've ever seen. Like a violin, just absolutely perfect. Zero effort, gravity works. Here it's just so nice. The bearings are actually provide enough pressure that they don't slip on this shaft. So really nice positive. There is no play, and yet you can see how easy it is to move. So I'm over the moon happy with this design. The 26 tooth pulley here is going to help a lot. Again, I mentioned this zero gravity coupling via the square shaft will actually rotate 20% slower, maintaining the same resolution, same print speed, simply by putting a reduction here. Before it was 1:1, 20 to 20 tooth pulley, and now I have 16 to 20 tooth pulley, so that keeps my print speed and motor speed identical. X-axis, belts linear speed is the same, resolution is the same. I already mentioned that, beginning to ramble. So that's how we make our own custom parts, totally DIY. Before this is a thing, we can make our own thing. So that's pretty cool, I think. Gotta clean up this mess and finish assembling the machine, and on to printing. One more quick announcement while I remember this. RepRap, Midwest RepRap Festival is coming in Goshen, Indiana, starting on the 12th, June 12th, 13, and 14. I will be there on the 13th only, so Saturday only. Hopefully you'll be able to see this baby in action. So Picolino, magnetic IDEX, a cooler class motion system, and now zero gravity coupling. All of these things will be featured on my booth at Midwest RepRap Festival. So anybody who's coming to MRRF, I hope to see you there on Saturday. I'm there only for one day, but I'll be there all of Saturday. So hopefully I can catch some of you there. Thanks to all my Ko-fi supporters. Thanks for picking up a Picolino extruder gear. Thanks for watching. Like, share, subscribe. Bye.